I'm happy you found it.
It was in the thing. Like this. It was in there.
That's a great place to hold it.
It just came apart.
Okay. All right, so just so everybody's aware, if you start watching this video, Bethany found the other half of her button. It was inside of her button all along. Wow, what a great ending to the story.
Isn't that fantastic?
Bethany, so solving a matrix. Solving a matrix. Guys, we're basically doing the elimination method, but we're removing the variable. So we're putting it inside of a matrix, which are those tall brackets that you guys will see on your note page. The end goal is to work it down to the identity matrix, which is ones diagonally across. Really, it's just make sure you only have a 1 and some zeros, right? And if it's a 3 by 3 like this one is, it's a 1 and 2 zeros in each row. And where the 1 is at changes. Ideally, we just, like pretty wise, we put them in so that way it's 1 in the upper left, 1 in the middle, 1 in the bottom right. Okay? 1 in the upper left, 1 in the middle, 1 in the bottom right. And then whatever's left over in the far right column, those are our solutions. It's important also that as we put these elements into the matrix, as we put each element into the matrix, that we put them in order. It's X, Y, Z, X, Y, Z, X, Y, Z. Now the rows, not the columns, the rows can be swapped. The rows can be swapped. You can swap any row with another row. You can multiply every element in a row by anything you want. You can add any or subtract any two rows to make a new row. It replaces one of the rows used when you did it. And then you can use any combination of that. If you guys want, take a fun twist on this until, it's all fun and games until, your 89th step. Then all of a sudden you're really bored and frustrated with the puzzle. But no, it's not going to take that many. So, but to each of you, it's different. How you approach the puzzle, how many steps you take to the puzzle, for each of you, it will be different. The more steps you can do, the more you can see and visualize the end game, the shorter it'll be to do it. So the best example is just jumping in both feet. Let's go ahead and do this. We're going to try to work our way to the identity. Please make sure you start in the upper left. So I have 4x minus 2y equals 2. 5x minus 2y plus z equals 7. 3x plus 4y minus z equals 3. And we're eventually trying to get it down to 1, 0, 0, x, 0, 1, 0, y, 0, 0, 1, z. That's the end goal. And what it's saying is 1x equals whatever this number ends up being. 1y equals whatever this number ends up being. 1z ends up being whatever number this ends up being. You'll see it, Bethany. Trust me, guys, because I'm going to let you do the first, half a dozen steps until I get frustrated, and then I'm going to finish it off. Okay? Who knows? So first thing I'm going to do is I'm going to write this into a matrix. So I've got 4, 5, 3. Those are my x values. My y values, -2, -2, 4. My z values, 0, 1, -1. Two, 7, 3. Huh? Those will be my solutions in the end. Does anybody have any questions on where I pulled these numbers? All right. I'll do the first one for you unless you guys think you got an idea on what we got to do. Okay. So remember, I can multiply rows by anything. I can add and subtract rows, and they create a new row 1, new row 2, or new row 3. Whatever row I use in my operation, it has to replace one of those rows. So in other words, if I use row 1 and row 3, that's going to make my new row 1 or my new row 3. It can't make my new row 2. I don't know. So I'm going to say row 3 minus 2 times row 1 equals my new row 3. Row 3 minus 2 times row 1 will make my new row 3. Yes? Oh. Nope. Nope. I don't know. No, it's one of the 2 rows I use will be my new row. So I use row 3 and row 1, so I need to equal it to be row 3 or row 1. My choice.
So you choose.
I don't know, Riley, they're somewhere. Because you weren't here, I can't stop right this second. Yes.
You just choose whatever you want to do.
Because you're trying to get this. You're trying to get this. So that means row 1 and 2 didn't change, only row 3 changes, right? We okay with that? So I'm going to keep talking. If you guys, I'll give you a chance to write in a second, okay? I'm going to keep going. If you choose to not listen right now, I'm not re-explaining. So row 3 is here. Minus 2 times row 1, so it'd be 3 minus 8, negative 5. 4, oh, I meant plus 2 times right there. Whoop. I'm going to change that. Okay, row 3 plus 2 times row 1. So, sorry. 3 plus 8 is 11. 4 plus negative 4, 0. Negative 1 plus 0, 3 plus 4, now I'll pause. Row 3 plus 2 times each one in row 1. Dimitri. Three plus 2 times 4 is 11. 4 plus 2 times negative 2 is 0. Negative 1 plus 2 times 0 is negative 1. 3 plus 2 times 2 is 7. I picked like a really bad, ugly step to go with first. Yeah. Row 3 plus 2 times row 1. Row 3's been replaced, equals row 3. I've got to replace one of the rows that I used in the equation. Okay. Yes. I can. Yeah. Yeah. What do you mean 2? Oh, why did I pick 2? I picked 2 so I want zeros. I want zeros. Okay? Now that might be a step that I end up undoing. This could be a bad step I chose. And I think it is. But I'm showing you the method. I'm showing you the method. I probably should have used row 1. I want to get zeros and then use the rows with zeros. Now I've got a 0 in row 3, so I'll probably want to use row 3 a bit. Let's see. So how about what? Maybe row 1. Yeah, it was a bad choice. Row 1. No. Yeah. No. Think I just made a bad call. Sucks. Oh well. You don't. All right, so I'm going to say row 1. Let's try to get. Let's try to get. I'm going to get this to be a 0 here. I'm going to go row 2 plus row 3. Row 2 plus row 3 makes the new row 2. Row 2 plus row 3 makes row 2. Mm-hmm. Row 2 plus row 3, so I get 16, negative 2, 0, 14. Mm-hmm. No? No? Because row 2 is 7, row 3 is 7. 7 plus 7 makes 14. Are we okay, guys? Where did I lose you, Michael? You don't know where I got any of those numbers from? Ah. So, Michael, I'm trying to work these zeros into it. I really don't care about the 1 so much. I'm trying to get a bunch of zeros. I want a 1 to be, I want only 1 1 here, only one. I need 2 zeros in the 1 row, 2 zeros in the 2nd row, 2 zeros in the 3rd row. Okay? And they need to be, because the way this matrix is set up, this represents 1x. So I'll get an answer. 1x, like if this said 1 0 0, I'd know 1x equals 2, so x is 2. If this said 1 0 0. If this said 0 1 0, I'd know y equals 14. And if this said 0 0 1, I'd know z equals 7. Okay? So I can multiply these rows by anything, and I can add and subtract them as well from each other to get a new row value. So I did row 3, okay, plus 2 times row 1. I did that because it'll give me a 0 right here, which is something I wanted. Getting those zeros is important. And I'll show you why. So now I got to that, and I decided I wanted to get rid of this 1 right here to get that 0 right there. Okay? So that 1 can cancel with that negative 1. So I just simply added them, and now I canceled that 0, that 1. Destiny.
So would like a good next step be row 2 minus row 1 equals row 1?
Row 2 minus row 1 equals row 1.
Then you get 0 on the top row.
Yeah.
So you just try to
That'll
get
work.
zeros?
Mm-hmm. Row 2 minus row 1 equals row 1. That's what Destiny said. So that means I'm keeping rows 2 and 3. So row 2, these can be long. Row 2 minus row 1. So what's 16 minus 4? 12. Negative 2 minus negative 2. 0. 0 minus 0. 0. 14 minus 2? 12. This is very helpful. See? No, they are X, Y, and Z. They are. Yeah, we don't have. Yeah.
So you can just like think of what to use, like the row. You could just think of your.
Yep. Now, this is an easy step. Row 1 divided by 12 equals row 1.
Oh, so you're allowed to do them to themselves?
Mm-hmm.
Like without any other row?
Yep. I've got my first 1, 0, 0. Yes.
So, can you divide row 2?
I don't want to do that right now. That would simplify it. I don't need to do that right now, though.
No, but to make that a 1.
Divided by,
Negative 2.
well, I don't know what I'm going to be doing with it, and it probably will eventually, but right now, because it's just kind of an unnecessary step as we go through.
How do you know what to do though?
Practice. I'm just doing it right now to save room. You might do that on your own, and that'd be fine. Nothing wrong with it. Because right now I can get the bottom row. How can I get the bottom row? No. No. This will be something where I'm subtracting. What am I subtracting? What from what? Mm-hmm. First row and third row, but I've got to do a multiple of the first row. So it's going to be row 3 minus 11 times row 1.
Equals.
Row 3. So we have 11 minus 11 times 1. 0. 0 minus 11 times 0. 0. Negative 1 minus 11 times 0. Negative 1. 7 minus 11 times 7. 7 minus 11 times 1. Negative 4.
So if we have to get the ones in the diagonal, but does it matter if they're negative or not?
It does. So I'm going to have to do row 3 times negative 1 equals row 3. So let's do a double simplification step here because they're both easy. So how about row 2 divided by 2 by negative 2 equals row 2. And we'll do row 3 times negative 1 equals row 3. Row 2 divided by negative 2 equals row 2. Row 3 times negative 1 equals row 3. 1, 0, 0, 1. Negative 8, 1, 0, negative 7. 0, 0, 1, 4. Elias, don't die. Whenever I write small and down in the bottom, I always think of Elias, and I look back, and he's dead anyways. All right. -8, 1, 0, -7. So now row 1 and row 3 are good. I just need to get row 2. I need to get rid of that -8. So I'm going to do row 2 plus 8 times row 1 equals row 2. Okay, row 2, -8 plus 8 times 1 is 0. 1 plus 8 times 0 is 1, 0. -7 plus 1 times 8 is 1. There's my solution.
Is that a comma? One.
Yes. Huh? Yeah. Tutoring. These are long. They just take a lot. Somebody said this makes no sense, or this makes a lot of sense. Somebody said something? Makes sense? Good. Help Michael.
So this is another method. It was hard to say that first.
Yeah. No, I know. This is one where I needed to start you guys off.
Just another method to solve for x, y, and z.
Yep.
Well, I know how to do this one now, but I don't know how to do the other one.
Why not? So, any complication? I know Richard's been out for almost the entire period. Yeah. No. Dimitri asked if it needs to be diagonal. That's just the way the answer is usually written. Just like this is x, y, z in order, right? If this said the rows are interchangeable. So if I had that, it means the same thing. It's just saying y is 1, z is 4, x is 1. You know, I need to have 2 zeros and a 1, and they need to be in different slots. They just can't be over, sure. Or
So just say like 0, 1, 0, 0, 1, 0.
can't do that, yeah. Because then you're saying y is 3, y is also 5. What? Is it 3 or 5? Make up your mind.
So where the 1 is, that determines what variable?
Yes. This determines what variable you're talking about. This determines what that variable is. 1 through 12 only. Do your workbook questions also as practice, please. Do 5 and 6 in your workbook as practice, and then only 1 through 12 in the textbook. Yeah, if you've got some sort of homework, if you got to turn in now, turn it in the back. If you don't want to turn it in now, get it to me by Wednesday. I thought you said knees at first, and I was like, what are your knees?
Yeah, no, my niece can't listen.
Your brother, like, asked, like, any graduate, if they ask me on social media, like, follows, like, friend, whatnot, I don't care, sure. Your brother, so Brandon asked me, and it's like, now I've got to block his feed, because all it is semi-inappropriate posts about women. And it's just like, I don't need to see this.